Sixth grade lesson 12.5 is mean as fair share and balance point. So sometimes you have a group who's working towards something as a common goal. And if you find the mean or the average of what they're after, then the work can be spread evenly or the results can be spread evenly depending on what's going on. Mean or average kind of tells you the balanced point of where things are at. And we'll also look at more of the balance point in terms of a deviation from the mean. So we'll get into it. Let's take a look at the examples. And I think as you see it, it will make sense. So this first example shows us with counters. And if we have counters, we can use them or we can draw them. How that balance point or how that mean or that average spreads is just trying to spread things out fairly. So this will give us a visual to that. On an archaeological dig, 5 students found 1, 5, 7, 3, and 4 arrowheads. Let me clarify that. So one student was in an area where he was able to find 1 arrowhead. Another student was in an area where he was able to find 5 arrowheads. Another one found 7. Another one found 3. And another one found 4. So that's what they mean by those numbers. The students had agreed that they would divide the arrowheads evenly when they were done. How many arrowheads should each student get? So we could use the counters to show how many arrowheads the 5 students found. So we had one that found 1, another found 5, another found 7. He must have gotten a really nice area to search through. And another student found 3, and finally the 5th student found 4. And so what they say is if you have these counters then all set up, then you can go ahead and redistribute them to make things equal. So maybe I take this one off of this stack and put it here on this stack because that guy needed some help. He ended up in a bad area of searching. And then I think I'll take this guy's off of here and redistribute it over there because he had lots to share. I'll take another one. He still has lots to share. Oh, it doesn't let me erase it. Now I'll scribble. That catches him up. And then we can put this one here. And now we have a fair amount. Each student is going to get 4 of the arrowheads. So when we redistributed that out to make it fair, because they agreed that's what they were going to do, the number of counters in each stack is the mean. It is the average of the data. The mean represents the number of arrowheads each student should get if the arrowheads are shared equally. There are 5 stacks of 4 counters, so each student should get 4 arrowheads. They want us to explain what is fair about the fair share of a group of items. What we're talking about is distributing everything evenly, balancing everything out evenly. So word that how you want to. What do they mean by fair? We're distributing or sharing things out in an even way. How could you find the fair share of arrowheads using the total number of arrowheads and division? Well, if I added up all of the arrowheads that were collected, and then I said, okay, we collect them, we put them all in a bin. Everybody, once you collect them, don't even think about how many you collected. Collect them, put them all in a bin. Then when we pour them out, we would divide them evenly, one for you, then you, then you, then you, right? We're dividing them by the 5 students. So in order to find the average, rather than using counters, we could take all of the arrowheads that were found, add that all together, and you would get 20. And we would take those 20 and divide it up into the amount of students we had, which was 5. And 5 goes into 24 times. So if I wanted to find the mean of something and I didn't have counters to model it, I could simply add up all of the data points and then divide by how many data points there were. So this next one in making connections, they say the mean can also be seen as a kind of a balance point of where you would kind of differentiate or spread fairly. So let's see their example here. The mean can, the Mrs. Burnham's class holds a walk-a-thon to help raise money to update the computer lab. 5 of the students walked 1 mile. One person walked 1 mile. Another person walked 1 mile. one person walked 2 miles, one walked 4 miles, and one of them likes to walk a lot. He walked 7 miles. The mean distance walked is 3 miles. Okay, I want to talk about that mean distance walked that they gave us for 3 miles. If we add up the 1 mile, 2, 4, and 7, we are going to get, so 7 plus 4 is 11, 12, 13, 14, 15. We're going to get 15. And we divide that by how many students walked that. There were 5. And 5 divides into 15 3 times. There's our average, our mean. Average and mean are the same thing. So we have an average of 3. And they say go ahead and finish completing the dot plot for the data set, where they went ahead and dot plotted the 1 for that, and the 1 for that, and the 2 for that. So we just need to dot plot the 4 and the 7. There's only one of the 4s and one of the 7s. So there's the completion of that. They say circle the number that represents the mean. That does. Okay. So we want to complete the table to find the distance of the data points from the mean. And we'll look for the ones that are less than the mean over here, and the ones that are greater than the mean over here. And by how much, right? So the 1 mile data point is 2 away, right? 3 minus 1 is 2. So it's 2 away, and they've marked that for us already, right here. The other 1 mile point is also 2 away. 3 minus 1 is 2. The 2 mile point is only 1 away. 3 minus 2 is 1. So the 2 mile point is 1 step away from the mean. And those were all less than the mean. So I could add these all together to find out how far, how many were less than the mean and by how much. 2 plus 1 means I have 5 miles less than the mean. Mean being kind of in that middle range. Some are lower, some are higher. That's always going to be that way when it's the mean or the average, because it's representing as much to the middle fair point or the balance point as possible. How many, this one here, how far above the mean? It's 1 above, right? 4 minus 3 is 1. And then the 7 data point, that is how many away from the mean? 1, 2, 3, 4. 7 minus 3 is 4. So of the greater ones, I have 1 mile and 4 miles is the greater amount for a total of 5. The total distance of the data values less than the mean, so all of these, was 5. The total distance of the data values greater than the mean was 5. The mean represents a balanced point for data values less than and data values greater than the mean. So explain how you found the distance of each data value from the mean. We subtracted, right? Well, we kind of looked at how many steps, but as I mentioned as we went, you could see you just subtract. What's the difference between the mean and the data value, the data set that you're looking at? And so you just take the larger number and subtract from smaller number because we're trying to find the difference, right? So we found the difference between data point and the mean. And that helped us organize how many were less than the mean, how many were more than the mean. And it should be fairly balanced if you've got the mean correct. It should be pretty close to the same amount. Can all of the values in a data set be greater than the mean? Would we ever have the mean, that number that's supposed to be representing a really kind of that middle part that has everything balanced, one on one end, one on the other, and staying nice and balanced? Could we ever have that be smaller than all of the data sets? Would that work if we had the mean right here and then all of our data sets were over here? And think of like a seesaw, a teeter-totter. Is there any way that this point is going to stay fair and balanced? No, right? You know, you've been on a seesaw. That thing's going to fall down. So you think of your mean or your average as that balanced point of a seesaw. And if we want to keep that thing balanced, it's going to have lower numbers and upper numbers, because what it's trying to represent is a fair middle that will keep our seesaw balanced. So if they say explain why or why not, there's my drawing of it and my explanation. Word in your words of why we could not have all the numbers be greater than the mean or all the numbers be smaller than the mean. The mean's going to have to be in the middle or we're not going to be balanced, are we? And that's all this lesson is about, is really just getting familiar with the mean or the average of a data set.